Now, once again from the beginning, see, here there are any elastic collision in, once again, what is collision? Interaction of two bodies is known as collision. Again, what is head-on collision? If the two bodies moving the same line, if all the bodies move in the same line, then that is known as collision, that is head-on collision. Next one. So we have elastic collision in one dimension and two dimensions, that I will explain. But what is perfectly elastic collision? There are two types, perfectly elastic, perfectly inelastic. Perfectly elastic means both momentum and energy are conserved. That is perfectly elastic collision. In elastic collision, momentum is conserved, but energy is not conserved. Then that is known as inelastic collision. And in perfectly inelastic collision, example is what? Two bodies, they move together. And after that, after some time, after collision, they stick together and they move together with the same common velocity. Then that is known as perfectly inelastic collision. So yeah, if you ask me, sir, is there any example of perfectly elastic collision? Yes, it is there. But it generally happens in the space. And one more example is what? Newton's canonical pendulum. You might have seen there are 6 pendulums, like one sticks and the other moves. Then again comes like it moves. Have you seen that one? Newton's pendulum. You might have seen like hanging, like it is hanged by two threads. Have you seen that? Any idea? So that is the example of perfectly elastic collision. Now, so in this derivation, so there are m1, m2 are the two masses whose initial velocities are u1, u2. This is at the time of collision. This is after collision, v1 and v2. So this is sum of momentum before collision equal to sum of momentum after collision, and sum of energy before collision equal to sum of energy after collision, kinetic energy. From 1, we took the equation number 1. We brought m1 terms together. We brought m2 terms together. Then take m1 common here. Take m2 common here. Then from 2, take this equation number 2. Then bring m1 together, bring m2 together. Then take half m1 common, half m2 common. Then simplify that one. Half, that is a square minus b square, a plus b into a minus b, do that way. Then divide equation 4 by equation number 3. Then the terms will get cancelled. So u1 plus v1 is equal to v2 plus u2. Then v2 equal to u1 plus v1 minus v2. Now substitute equation number 5 in equation number 1. Equation number 5 in equation number 1. Then what will happen? In the place of v2, we are going to substitute that. Then open the brackets. You get this one. We have to simplify this. First copy this, then we will go ahead. 3 more steps. Okay. So what we are going to do is, we are taking the same step. Just bring v1 terms together. Look at v1 terms and bring the other terms together. So m1 u1 plus m2 u2 minus m2 u1 minus v1, just keep it together, plus m2 u2 equal to m1 v1 plus m2 v1. Now what will happen now? m2 u2, m2 u2. See here, implies we can take u1 common, m1 minus m2 plus this and this together, 2 m2 u2 equal to m1 into, sorry, v1 into m1 plus m2. See carefully again, m1 u1, m2 u1. u1 I have taken common, m1 minus m2, and m2 u2, m2 u2, that will become 2 m2 implies. So what we are going to do, v1 equal to what? u1 into m1 minus m2 plus 2 m2 u2 divided by m1 plus m. So this is the equation. Yeah. Is it clear? So this is the final equation. This is the way to find out the v1 value. So there similarly we can find out the value for v2 also. How will we do that? Similarly, how will we do that? v1 equal to what? Here the same. v2, right? I will write here. Similarly, u1 plus v1 equal to v2 plus u2. So I want v1 equal to v2 plus u2 minus u1. Now again substitute here. m1 u1 plus m2 u2 equal to m1, what is v1? v2 plus u2 minus u1 plus m2 u2, m2 v2. Okay. So what will happen now? Now m1 u1 plus m2 u2 equal to m1 v2 plus m1 u2 minus m1 u1 plus m2. So now, so now what I'm going to do? I want v2 terms together. Okay, I want v2 terms together. So what I'm going to do now? So leave that v2 terms, v2 this and this you leave it and bring the other one together. m1 u1 plus m2 u2 minus m1 u2 plus m1 u1 equal to m1 v2 plus m2 v2. Now here m1 you take common, u1 minus u2 plus m1 u1 m1 u1. Okay, so that will become 2. So here I can take u2 common, m2 minus m1 plus 2 m2 2 m1 u1 equal to take v2 common, m1 plus m2 into v2. Cross multiply v2 equal to u2 into m2 minus m1 plus 2 m1 u1 divided by m1 plus m2 into v2. So m1 plus m2, yeah, that's it. So this is the second velocity. Clear? So you need to learn this one, v1 and v2. So they will give in the numerical m1, they will give out of 4 variables m1, m2, u1, u2, v1, v2. Out of this, they will give 4. You need to calculate this 2. Okay, how to do that? Use this formula. And very important for the entrance exams also. If you are preparing for NEET or JEE, this is very important. So out of this, definitely one question will be coming. So this is a general formula. Now, suppose if m1 equal to m2, there are cases again. What if m1 equal to m2? If m1 equal to m2, this will become 0. This will become 2m, like that. If m2 is much greater than m1, very high, then yeah, m1 can be neglected in that way. So we will do some cases also. Please copy this. If you are in doubt, please ask me.
Sir, what were you, sir?
Yeah. See, m1.
What were you saying when?
I mean, in this numerical, we have v1 and v2, right? I am giving you m1, m2, u1, u2 to you. You are going to substitute here and you will find out what is v1 and what is v2. Okay. You will find out what is v1 and v2. You will substitute all the values in this formula and find out v1 and v2 value. Is it clear?
Okay, sir.
Okay, please do it now. Elastic collision in 2 dimensions. Okay. Now, elastic collision in 2 dimensions. So in this, what happens? This is m1, whose initial velocity is u1. This is m2, whose initial velocity is u2. So what will happen? Now they were in same line, but after collision, what happens? So this, okay, I'll write here, I'll draw both. This is m1, m2, this is at the time of collision. After that, what will happen? This is m1 and this is m2. m1 will go with a velocity theta and this will go with phi. Theta and phi. This is m1 u1, this is v1. This is v1 and this is v1 and v2. So what is the formula now here? The formula here is
Sir, how I can?
Once again from the beginning, see, there are two bodies, M1, M2, whose initial velocities are U1, U2, they collide. Now they are not going in the same line. They are moving in a plane, okay, in two dimension. Like M1 goes with V1 and M2 goes with V2. Like, have you seen the billets, English pool or French pool billets? Did you see any time we hit and they go in a different direction? Anytime did you? Yes, no one saw. No one know how to play the billets.
Yes, sir.
Yeah. So we have V1 and V2. Now what will happen? We need to find out the the components. So what will happen here? Use the same formula. So same M1 U1 plus, this is momentum is conserved. M2 U2 equal to M1 V1 plus M2 V2. Similarly, we have half M1 U1 square plus half M2 U2 square equal to half M1 V1 square plus half M2 V2 square. This is energy is conserved. Now what we are going to do now? For this, we have two components. So we have horizontal component, we have vertical components. Okay, we have horizontal component and vertical components. Now, M1 V1 cos theta, here we have two components. This is M1, this is V1, this is theta. So what will happen now? M1 V1 cos theta, M1 V1 sin theta. Similarly, for this body, this is M2, this is phi, this is V2, M2 V2 cos phi, M1 V1 cos phi, M1 V1 cos phi. So we are only taking the horizontal components. We are not going to take the vertical components. So what happens now? M1 V1. So here we have M1 U1. So the first formula is M1 U1 plus M2 U2 equal to M1 V1 cos theta plus M2 V2 cos phi. Why cos we have taken? Because this and this is in the same line. This and this are in opposite direction. M1 V1 sin theta and sin phi. These two are in the opposite direction. Sin theta and sin phi, they are in opposite direction. We are not going to take them. So if you take the vertical component, this is for the horizontal components. If you take the vertical components, it will be 0 plus 0. Because there is no vertical component here. And vertical component is here what? 0 plus equal to M1 V1 sin theta minus M1 V1 sin phi. Minus M1 V1 sin phi. So what will happen now? So M1 V1 sin theta equal to M2 V2 sin phi. M2 V2 sin phi. This is the formula for two dimension. Okay. Is that clear? So this is that's it. He hasn't given much in the detail. In the textbook also, he just explained only the components in two dimension. That's it. Is it clear, girls? Just they will give the angle, you need to substitute in the angle. Okay. So this completes your lesson. If you have any doubt, please ask me. So formulas. The first one, A dot B equal to mod A mod B cos theta. Second one, cos theta equal to A dot B divided by mod A mod B. Okay. So here, if theta equal to 0, in that first case, theta equal to 0. So cos 0 is 1. Second case, theta equal to 90 degrees. Cos 90 is 0. Third one, theta is 180 degrees. Cos 180 is -1. Third one, we have work done is equal to force into displacement, F into D cos theta. Okay. Or also we can write F dot D. Fourth one. So we have what? Kf minus Ki is